Okay, today's presentation will be from Joellen Russell, University of Arizona, and she is one of the co-chairs of the Southern Ocean Working Group. This working group is joint between U.S. CLIVAR and the Ocean Carbon Biogeochemistry Program. Thanks, Joellen. If you'd like to, you can go ahead and get started.
Yes, hi, welcome. This update on the Southern Ocean Working Group would not be possible. In fact, the working group would not be possible without the support from OCD and U.S. CLIVAR, which we've really enjoyed. Thanks, Kristen and Mike and Heather Benway, et cetera, from OCD. We really appreciate your support. And when I say we, I mean me and Igor Kamikovic, who is a professor at the University of Miami and my very good friend and colleague who is the co-chair of the Southern Ocean Working Group. So we're the Southern Ocean Working Group, and when we means Igor and I, as well as CC Bitts, Raf Ferrari, Sarah Yelly, Bob Hallberg, Ken Johnson, Irina Marinoff, Matt Maslow, Jorge Sarmiento, Kevin Spear, Lynn Sally, and Rafwan Croft. We were so delighted to have so many, really experts in the Southern Ocean and in both the physics and the biogeochemistry, both the observations and the modeling, willing to help us with the Southern Ocean Working Group. So our goals were to improve the understanding of the role of mesoscale eddies in the heat and carbon uptake by the Southern Ocean, and improve the understanding of how the Southern Ocean stratification, circulation, and heat and carbon uptake respond to changing climate. I'm going to show you what our outcomes and deliverables are. So the main things we promised to produce were a workshop or conference jointly sponsored with the Ocean Carbon Uptake Working Group at the Fall AGU, with the goal of sharing the metrics for model evaluation. They're doing sort of global ocean carbon uptake, and we were doing Southern Ocean with Southern Ocean specific focus. But we have metrics that are relevant for each other's work. Identifying important biases in the AR5 CMIT5 type model simulations of present and future climate stemming from the lack of mesoscale eddies and other flaws. And providing guidance for estimating, reducing uncertainty in climate projections. And we hit those targets, so I'll talk about that in a minute. We also said we'd produce a manuscript for the Journal of Climate that assesses the state of our understanding of the role of eddies. Now, this has been downplayed somewhat in that the number of CMIT5 or other models available that have eddies in the Southern Ocean. We'll show you some of our results do have, but it couldn't be the main target, as biogeochemistry and eddies are both cost functions in the models, and higher res and more complex biogeochemistry is hard sell, so there are only a few. And then 2, identifies the most critical observational targets needed to fill in gaps in our understanding of the role of the Southern Ocean in present and future climate. And this is where we really pushed along in our results. So observationally based data model metrics are a consistent evaluation of modeling efforts by the Southern Ocean and Arctic scientists. We've hit that target, and that'll be available both in a Southern Ocean Climate Model Atlas website, and if you'd like to do your own calculations or use our scripts, et cetera, they'll be available in the Discovery environment on a new iClimate website also available this summer. So, and then we're producing a summary of our working group activities and products for the U.S. CLIVAR and OCD newsletters. So the Troit Workshop. This was organized not just by the Southern Ocean Working Group. It was mostly Heather Benway, Emily Zabracco, Curtis Deutsch, John Fife, Taka Ito, Igor Kamikovic, Mike Patterson, and Kristen. Boy, was this a group effort, mostly our program office folks. It was a lot of hard work. So this was uncertainties and metrics, and I just enjoyed the heck out of this. It was a lot of fun. So our plan was to build upon and synthesize the working group's efforts to develop metrics, estimate the uncertainties, inform future observations, model development analysis strategies, and it was organized into 5 main sessions: model biases and uncertainties in Sigma 5, observational gaps and uncertainties, meaning if you don't have an observational target, it's really hard to assess your model against it. Process studies, where do we really need to actually understand better how an individual process or measurement needs to be made in order to get to a parameterization. And then the Southern Ocean, we had an actual Southern Ocean session, circulation and carbon cycle, and new initiative. 82 attendees, including academic, government, and non-government scientists from 20 non-U.S. organizations representing 9 different countries. It's pretty fantastic. We've had a lot of heavy hitters in the room, too, and some great young scientists as well. So out of the modeling session, I'll just quickly run down the recommendations that came out of each of the 5 sessions. I know that sounds boring and it's a lot of text. I will try to simplify. So the plan was to, the modeling session recommendations that came out of some fantastic talks. You can find most of the PowerPoints are online on the US CLIVAR website, which was terrific. If you're interested, they were fantastic. So derive observational metrics that cross boundaries between atmosphere, ocean, land, and cryosphere. It's amazing how rarely this gets done, and can identify biases in couple dynamics and associated feedbacks. We had some terrific people here who helped really push this ahead. Evaluate and address model biases by identifying processes mechanisms, not simply just documenting the model errors. Everybody had a piece with that, which is fine. You can tell us if this is wrong, but tell us why is it wrong. Help us, you know. And then the need for a comprehensive CMIP-5 analysis package. And we're working on this. There is going to be a CMIP-5 CMIP-Val tool and some PCMBI metrics available. We're also in direct talks with Southern Ocean Working Group co-chairs of direct talks with Veronica Ehring about the CMIP-Val and including the metrics that we developed through this process into CMIP-Val, or potentially linking to theirs, since ours is pretty comprehensive for the Southern Ocean these days. Also, the community should conduct idealized sensitivity simulations to establish key processes. There's still, basically, out of this, I got this, everybody in the water. We need a lot more work done here. It would be great if the funding situation were better. Coordinated observations and modeling efforts can go a long way toward identifying biases and reducing uncertainty in climate simulations. So from the obs session recommendations, calibration. You've heard about location. This is calibration. Critical and newly emerging programs like, I don't have readily available well-documented procedures. It's difficult to calibrate rates. There's a strong need to fully document methodologies and changes in methodologies. We need standardized climate quality biological measurements. We're missing this almost entirely. More data synthesis and analysis efforts, critical to fully exploiting rich data sets, but many of the efforts to date have been done on shoestrings, like GLODAP and GLODAP2. Agencies need to prioritize this to get full return on their investment in the observation. This was a hard, there's two exclamation points there because it was heartfelt here. More coordinated efforts to observe atmospheric and oceanic processes concurrently. If there's a big program in the atmosphere, we need to get the ocean, we need to get the floats out, we need to get the ships out. If we're having a big program in the ocean, we definitely need to be making, whether it's glass or airplanes, we need to coordinate because we're starting to get at the temporal and spatial variability. More deep ocean measurements. Expand deep Argo, woohoo, and measurements under the ice. The software fixed for floats so that they can avoid the ice is a fantastic new feature of the Argo floats. So Southern Ocean session recommendations. The use of observationally based standardized metrics is the best way to evaluate and compare models to move toward reducing uncertainty. Observationally based metrics, not just and standardized. A rigorous assessment of input of wind energy to the ocean and uncertainty, spatial and seasonal, associated with the observing system as needed. This was the big highlight of the workshop. Coordinated program to observe and model both oceanic and atmospheric biogeochemical parameters at the same place and time, process study oriented. There's an increased need for both top-down tracers that reveal sinking like CFCs and bottom-up tracers. And this was something that was repeated at the workshop, like radiocarbon, that reveals ventilation, bottom-up. We need to assess the role of winds and the change of the strength of the antarctical current and the role of eddies both in the ocean and in the models. This came up in many talks. And then process studies recommendations. Role of eddies at low and high latitudes in rough topography and not, in high speed and low speed current flow. The dynamics in coastal upwelling zones, including the role of eastern boundary currents. In fact, this looks like the list I'm sure I'll be using in another 10 years. These are all classic problems: ocean convection, overflows, and mechanisms of iron inputs to the ocean, which are ongoing, important, and need to be expanded. So the workshop report's being edited by the organizing committee. I sent a full draft out, and when everybody's got their edits in, we'll finalize it and should put it up on the web this summer. And by summer, I mean by the end of August. So hopefully. All right, so in the metrics, what did we do on the metrics in our metrics paper? So every one of the members of our committee volunteered their favorite metric for the Southern Ocean. For CC-BIS, it was sea ice extent, volume, and seasonality. For raw variety, it's eddy kinetic energy, eddy-induced diffusivities, and heat transport uptake. And Sarah, it was mixed layer depth. I could go through this whole list, but essentially they all gave us their their best bet. And we did have to do a little horse trading to make sure we didn't overlap because everyone wanted to say oxygen. Okay, so we have a paper now, a draft paper that's out, that's been gone through its first set of revisions and is on to the second round. Metrics for the evaluation of the Southern Ocean and coupled climate models and our system models. And this will likely be submitted to the Journal of Climate also by the end of August. That we have another round of edits that we'll probably do here. And I wanted to show you some of the results from this. So Southern Ocean metrics in the majority of the deep ocean, observationally best metrics associated with Southern Ocean circulation. And this is a wind tally plot after an OBERS plot. I put the circles on to actually where we're actually going to show you some of the metrics that we have. And what I'm using as metrics are basically observationally based. If I don't have an observation, I can't use it as a metric. So people will say, well, why didn't you show me the overturning stream function? Because I don't have an observationally based metric for that in the Southern Ocean. I don't have an observation. Well, there are some inferences I could make, but not a direct ops. Okay, for westerly winds, the source of virtually all of the momentum in the Southern Ocean. Effects depend critically on the latitudinal structure, drives upwelling and downwelling, plays a key role in balancing density structure, acts to weaken stratifications, and the models continue to exhibit a northward bias in the location of maximum wind stratus. And I give you an example of just some of the models, and we have an observationally based CFSR estimate, reanalysis product estimate in A, as you can see. Let me see, let's get an arrow here. This is our OBS. These are different models, and this is the zonal structure. You can see the black line is the furthest to the south, and all the models have a mean position significantly equatorward shifted from the observations. Here is the CX extent, the maximum in blue, the minimum in red, and we have the integrated area. You can see seasonally, this is from January through December. Notice that they have different structures, different totals. So while we can give you the average, it doesn't really give you just how far out some of these are from OBS. Some of them are not too bad. And this black line is, again, an observational reanalysis product. Here is the maximum mixed layer depth, indication of the stratification of the water column, the depth to which wind forcing can penetrate into the ocean. The deep wintertime mixed layer South Australia is associated with subantarctic mode water. I just want to point that out. This nice blue line. This is from the World Ocean Atlas 09, not the 13 with the Argo data. And you notice that some of the models have this blue structure, and some of them it's entirely missing or not in the right place. And several of the models have excessively deep mixed layers in the Weddell Sea and or the Ross Sea due to persistent convection. Here is the sea surface height, and this is an AVISO calculation of the sea surface height, a sea surface calculation using AVISO. An indication of the barotropic circulation around Antarctica affected by density and steric height anomalies, to an indicator of heat content as well as winds and velocity. There's significant flow along the bottom, so direct connection between the sea surface height gradient and the total flow may be skewed, especially in models with idealized topography and or significant differences in the stratification on both sides of the ACC. So caveat, caveat, caveat. Notice that they are very different. The CSIRO model, the MRI model, and here's what we think is what reasonable observational target. So here's sea surface temperature error. Up here is what the sea surface temperature actually is. And I know it's made much too small to see the details, but it'll be in the papers. You can check it out. But here are just the differences from the World Ocean Atlas, just so that you can see there are big biases. You'd say, well, why don't you show us the seasonal, et cetera? Well, I could show you the seasonal, but just doing the annual average is bad enough. The differences are primarily due to circulation and are wind biases and not due to net air-sea heat fluxes anomalies that can affect heat uptake. Here's just the thickness of the less than 2 degree layer, an estimate of where our very coldest waters are being formed. Here it is in the World Ocean Atlas. Of course, it's present in most of the models, missing a couple of them, the warmer models, or very, very thin. Model simulations that simulate deep uptake of heat have been slow to have relatively reduced atmospheric warming they have been shown to have relatively reduced atmospheric warming under increased greenhouse gas scenarios. This is important. Here is an inverse type analysis where the volume flow is mapped onto density layers and then calculated across various sections. And all the sections are pretty south, so that we can compare to the layer definitions in Tally and her results. So in the background, what you see, these little boxes, the pink boxes, are actually Tally's estimates. So it's the same in every one of these. That's sort of our standard, what we expect from the Tally analysis. And then the models in the same density classes, which remember is going to be an issue because not all the models form the same temperature of same density of water in the same layers. So what we did to think about whether we were getting canceling due to heaving or changes in the definitions is we sliced them up into very fine density layers so that we could actually look at where the individual layers, these very thick layers in Tally were distributed, so you could see. But generally what you see is that we have 2-week transport generally, particularly in the bottom waters, and that at least in 2 of them, we have way too much very, very dense water. Notice that it should be next to 0. That's very big. So we also did PGE Chemical Metrics where we had ops, and this is a big challenge because we have many fewer observations. So the Ekman-driven surface divergence brings the old carbon-rich low pH water to the surface. Several simulations have excessively alkaline waters north of the ACC, and several have too acidic water in the upwelling region. Notice, wow, my rock. Here's the surface DIC, and again, we're comparing to GLODAP here, and here is what we think it should be from GLODAP. Here is what each of the different models did. We could actually look at an Atlantic section of GLODAP, and you can see that, in fact, the structures are very different in the different models. I'm sorry it's so small, but we wanted to give you the depth dimension here. And I wanted to mention just here at the end, so those are the metrics. I'm sorry, I should have had a transition slide here, that we're really hoping to get more observations to support this sort of analysis in the Southern Ocean. And it's very exciting to be part of the Southern Ocean Carbon and Climate Observations and Modeling Group project headed up by Jorge Sarmiento and Lynn Tally and myself and others. But it will have near 200 biogeochemically censored floats with pH, oxygen, nitrate, and on some of them optical sensors, in addition to the usual temperature and salinity from our lovely Argo floats. And this is really exciting. Matt Maslow is also involved. This is, and he's doing the Southern Ocean State estimate. So this is a really exciting time to be doing Southern Ocean work. We've produced this actually separately funded a Southern Ocean Climate Model Atlas, which just happens to be rolling out at the same time, and we've benefited from the choices and advice on the metrics for the metrics paper for the Southern Ocean Working Group. So you'll be, if you'd like to be able to do these, see more details of these metrics, you'll be able to see them. It's not live yet, the Southern Ocean Climate Model Atlas, but I'm assured by the undergrads and grad students and, that we are just about done filling it out. And the scripts to actually make these plots will also be available. They'll be available through this iClimate Discovery environment, which we're creating a climate data analysis portal. It's allowing users to upload and share climate model data, which we, not just the PCMDI, but also PRESA studies, et cetera, and the observational data sets against which they're assessed. And it's not that we're aggregating them here, we're just portaling to them, sort of like the IROD's front end at PCMDI allows us to pull from PCMDI really efficiently. And you can run, it will actually go find you the compute itself. And we're in the testing phase now, beta testing, and it should be available to the public in the fall of 2016. I'd love to say September, but it might be October or November. But we're pushing very hard. So one last thing, as part of the SOCOM project and out of some of the needs that expressed by the working group, we're submitting a Southern Ocean Modeling and Comparison project to the WPRP to be included in the CMIP 6. And the overall goal would be to reduce the uncertainties in climate projections by defining the role of the oceans in climate with regards to the Southern Ocean, especially the role of winds, buoyancy, stratification, so we can start testing more dynamically the actual problems we have with equatorward shifted winds and a polar shifting wind climate. And the objective is to encourage the climate modeling community to use newly created assessment tools by SAOG, et cetera, by developing a protocol for an international modeling and comparison program, at least one particular project within that. Sorry, it's not a program, it's a project. And the main thing we would be doing is zonally uniform wind perturbation focused on the Great Passage or momentum change. The protocols are being discussed now. And we're hoping to have that also submitted. And we have funding to carry this work out from the National Science Foundation as part of SOCOM. So another great outcome from our working group. So the Southern Ocean Working Group conclusions: we need to reduce the uncertainty in our projections of the Southern Ocean's role in climate. We need more in situ biogeochemical observation in the Southern Ocean, including floats, ships, moorings, etc. VGC Argo, we're hoping, global. We need more Southern Ocean climate process teams, and I'm really excited about the fact that there'll be a scoping workshop in October at UCL for potential new climate process teams, and I'm hoping they will consider the ocean's role in climate, not just the heat uptake, but also the carbon. We need more observationally based climate model metrics, although we've got a good start on that. There's more to do, especially on the biogeochemical side. And we need a Southern Ocean modeling comparison project, which we are underway. So that's what I have today. Thank you.
Great. Thanks, Joellen, for that nice presentation. Okay, we'll take any questions or comments that people have. Feel free to either raise your hand or type them in the chat box. And if you raise your hand, I'll take you off mute.
Nobody wants to give me a hard time? Oh, come on.
Oh, Mike is going to. Okay. 1 second.
Yeah, Joellen.
Mike,
very nice.
Mike.
Oh,
Mike,
sorry.
hi. Sorry, you were on mute. Now you're off. Go ahead.
Okay, great. Very nice presentation, Joellen. And just a quick question in terms of, so in seeing these great metrics that you've developed both for the physical and the biogeochemistry, can you point, especially when I was seeing that dissolved inorganic carbon slide, if you want to go back to that, are you also able to begin to get at what physical processes may be responsible for this disparity across the models?
We are just talking about that, and we'll actually indicate what we think the major issues are, again, categories of models, essentially. You use the CMIP-5 as a data set, basically, one big mini Earth, if you know what I mean. Each one a little bit different. And looked at it as a number of possibilities of ways the same equations can be solved, but they are not all the same, even though same equations. So we look at this and we can basically categorize the model. Some of the models don't have an appropriately sized and density of temperature and salinity of Northland seafloor that's being pulled in below the sill. Some of the models have really inappropriately placed winds. The westerly winds are too far equatorward, which means that their mixer depths are too shallow right in the axis of the current, and seasonally are inappropriately located north of these steep mixers, and basically which should be the subtropical gyre. We also have, so we have models with not two equator shifted winds. We have models with not the right amount of Northland seafloor. We have models that actually have some problems with their sea ice model. It seems to be misbehaving. Similar temperatures, but very different sea ice extent, which is always interesting. So we'll actually make a whack at this, at categorizing in our metrics paper. But the main object of the metrics paper is to get that, is to actually give our best estimate of metrics that really separate the models, meaning let you see what their major issues are. And the actual categorizing of the different models into these sort of bigger categories of whoopsies, that if we don't have a definitive answer in this paper, there's a subsequent in the comparison paper that we're planning on submitting.
Well, great. And so another follow-up question then. So in terms of our pathway,
and really exploring this is going to take that SOMIP, right? So
right.
Dynamically exploring this is going to take a SOMIP, which we recognize and are working on. So
Right. So will that be set up in such a way that you could really get at the connectivity between the processes and then
yes,
these output
absolutely.
metrics? Yeah.
That's the plan.
Okay.
I see Art has his hand up too.
Yeah, and so real quick before we go to Art, Rafael Ferrari had a quick kind of question comment. In the Southern Ocean Model Intercomparison Project, you mentioned winds, fluxes, and stratification as key variables. Shouldn't you also add the sea ice extent as well?
You're right, except that I always see sea ice as kind of, and I know Cece would probably deal with me, but I always see sea ice as a kind of the canary in the coal mine. I'm not sure it has, I think the sea ice, most of the sea ice errors that we see in a fully coupled model are due to inappropriate wind placement and potentially water mass formation. But that is a really active, ongoing area of research. It's been something that I think is a really big challenge, particularly in a coupled model. I'd love to see if we had appropriately placed winds. No coupled model has them yet. None of them get them far enough forward. Not any that I've ever seen. So at an roughly appropriate wind speed. So I don't know if that will help, but that's my bet.
Great, and let's hear from Art. Art, you're off mute if you'd like to ask a question.
Yeah, hey Joellen, this is Art. I'm just going to continue to ask about that northward displacement of the winds. Are there atmospheric scientists that are trying to identify what the issue is? Is it something to do with the radiative balance over Antarctica that doesn't get the clouds very well, or is it that there's actually pretty good vertical structure that it's just not reaching the surface at the right spot because of problems with the boundary layer in the atmosphere? Or also, is this something that's historically been around, or is it just in this set of models that it's doing that?
No, it's all of the winds moved as we got rid of a couple of the models that was most inappropriately placing their winds. When we moved from CMIT 3 to CMIT 5, we got slightly better. And just by the way, at the same time, we got slightly better ACC. But the main, yes, there are many atmospheric scientists working on exactly this. And there's a fantastic paper by Tom Bracegirdle, in fact, a series of them from the British Antarctic Survey on the observations versus models. And one of the major problems is that many of the CMIT 5 models didn't have an appropriately layered stratosphere. And the jet is positioned at the interface between the troposphere and the stratosphere. It's not just the sea surface temperature gradient. We all think about it being the meridional sea surface temperature gradient that sets the position of the westerlies. But in fact, especially in anthropogenic times where the stratosphere is cooling and the troposphere is warming, the stratosphere has cooled a lot, like 4 degrees in the tropics and 7 degrees over Antarctica, that essentially, unless you have a very well-resolved stratosphere, instead of getting a polar vortex where you're basically getting a deep downwelling essentially of polar stratospheric air, instead what you're getting is kind of a dimple or a divot, which is just not going to give you the appropriate gradient, pressure gradient that you need to put the winds in the right spot. And it's bad in the summer, but it's particularly bad in the winter. But essentially, it's this. I would argue that resolution in the stratosphere, high top models with higher resolution, so that you can resolve the polar vortex, is probably essential. But again, it costs money, right?
Right.
Adding more layers in the atmosphere costs you money. So, but that's my favorite explanation. There's more. They will tell you about There actually, when I counted them up, I have a slide. There were 14 different explanations, 14 currently. But my favorite is we're just not doing the stratosphere-troposphere boundary correctly, particularly in the seasonal change.
Okay, sounds good. Thanks.
But we're looking at it, and that's why to do it in a couple model, because we think that fixing the winds and just looking at ocean circulation just isn't going to cut it. Because when we get put back into a couple model where they're not being fixed winds, then we end up with we've tuned our ocean to this correct atmosphere, but that's not actually what we're being fed. So it's exciting and difficult.
Great. Thanks, Joellen. Do we have any other questions before we end today's webinar?
Thank you all for coming. I appreciate it.
Thank you all for your time, and thank you, Joellen, for presenting. Everyone have a good day. We'll be sure to share a recording of this webinar this afternoon. Have a good one. Bye-bye.
All right, I signed off. Am I good to go now?